All right. So what did you guys had last week? Last week you had REST APIs, Postman. Okay, and you did the simple, yeah, let me check. Let me check. Yeah, simple REST demo. And that's with the students, right? So we have a simple storage. So everybody understands the parsing of JSON and JSON data structures and mapping between JSON textual and JSON structs in Go? Or do we need to go over that? Do you can use it? Yeah, yeah. You didn't understand? All right. So who understands what JSON is? Okay. So can you say what is JSON?
Some kind of formatting for JavaScript, and the good thing about it is that it's easily good for human and also good for computers.
Right. So JSON is a textual data format, like here. So this text between the curly braces is JSON, and it's basically key value pairs, and the key is a string always in quotes, and the value can be either a number or can be a string or can be a bool, true, false, or can be a nested object, right? So if there is a curly braces here, so if I have something like so let's just use this space here. So if I have a JSON which looks like this, and it has person here, and I have a nested object inside, I can have other properties such as name, right? So now I have an outer object which has a single field person, and that person field has a nested object which has a single key value pair name Mariusz, right? And I can have sex male, right? Yeah. Say it again. In the same file? Yeah, so you can write those JSON objects as, because this is basically a string, right? So if I have the whole thing defined as a string, then you can write it in the same file. Or usually what we do, we generate them and we process them through some channels. So your web server will be serving content using JSON, and then you will be consuming it. So you usually don't write it by hand. You kind of generate it programmatically, and then you consume it programmatically. But this effectively is just string. And because it is a string, then you have to escape those inner quotes if you quote the if you quote the, if you want to quote the whole string. So you technically you could write it in one line. I just wrote it in a multi-line pattern, but if you do, then you have to escape the quotes, inner quotes, because you have, you have the outer quotes delimiting the string, right? So if you do this, and close the quote and escape these quotes, then you have just one string, and that's JSON, right? For pretty printing and for human readability, we usually split it into multiple lines, but it's just a stream of characters, right? So it doesn't matter for the computer if it's just one line or multiple lines, yeah? Yeah, exactly. So this is just a string, and then in Go, we don't want to process it as string. We want to have a structured data structure, which in Go is a struct, right? So instead of dealing with this as a string and like finding, oh, where is sex of this object and so on, what we really want, we want to have something that looks like this, which gives us kind of an easy access to the fields which the JSON represents. So in the student case, we have three fields. We have name, age, and student ID. And this would be a string. This would be just a JSON string or stream of text. And we don't want to deal with it as text. We want to deal with it as a struct. And to convert this string to the struct, we need to do some parsing and some conversion to a data structure, right? And we need kind of a generator and a parser. A generator converts this structure into a string, and the parser converts this string into this structure. And this machinery is built into Go, so we don't need to write it ourselves. We just need to tell Go how to map from those fields to those, and from those to those. And to do that, we use these annotations. Oops, sorry. We use those annotations at the end, right? So what this annotation means is that when the generator will be converting this structure to this string, it will use the property name and content of this field to generate this line, right? If I change this to, say, name2, the name of this field would be name2 instead of name. So the name of this field is taken from this annotation. This name doesn't matter, right? By convention and for sanity, we try to match those names, because if I call this name H and it's actually a name, you go crazy after a while because you have a mismatch of what's in the JSON and what's in your structs. So it's a very good idea to make those names exactly the same, but you don't have to. So sometimes those names use camel case, and those names use minus or underscore delimiters. Those names can be longer or shorter. Sometimes those names are longer because you want to be descriptive, whereas those names could be short. Like I could have called this just ID, so this would be just ID, but I don't want to deal in my code like, okay, what ID is that? I could call it student ID, right? But by convention, we usually match those names exactly the same. So then it's easy to see the JSON and see the struct, and you know what's what. But you don't have to do that. And then you have type safety, right? In the text, I don't know what all those things are. I don't have type safety, it's just text. But here I have a type safety. So if I said age is an integer, I expect that the value of this field has to be an integer. If this value is a string, something will throw an error. Something will say, okay, your JSON doesn't match what you expect, and there will be a parser error, right? So the parser will take this structure and try to fit the data from the text into that structure, and the printer will take the structure with the values and generate the string, right? So that's the kind of a parsing and generating, or marshalling and unmarshalling, right? So we use different terms for this process. When you convert a particular data structure from an internal representation into something else, we call it marshalling, and then you kind of unmarshal it back to the original. So more questions about this? Yep. Yeah. Good question, right? So that's a good question. So JSON, as we were writing here, has, so I will kind of remember it's just a string. I will not write it as a string because it's a bit more tedious. So I will write it again like I did originally. So this is my JSON object, and let's say I have a single student and I have a name, and that's student 1 and so on. And I now I want to have more of them, right? So you could say, okay, there is a new student, and this student name is stat2. So if that happens, you have two options. So one option is you could say I have an outer object which has those students as sub-objects, but then you need to have keys, right? And sometimes we do that. Sometimes when we have a database, key value per database, we would say I have two students now, and I will have a key which denotes me the first student, right? And I will have a key 2 which denotes me the second student, right? So I will have key value pairs. So I will have kind of keys in my object here, and I will have those students, and then you can look them up by key, right? Because if I convert this data structure to my struct, I will have keys with objects, keys and objects. So what is it? It's a map, right? So it's basically mapping some identifier, some key to my object, right? So if you have, let's say, 200 students and they are identified by some primary key, you can have a map which says, okay, I have 200 items in this map, and the key is the ID of the student and the value is the object, right? And this represents basically this map, right? So I have the key and the object, key and the object, right? And this is a single object. It's a single map. So that's one option, to have multiple students in a single JSON data structure. The second option is you say, I actually don't care about the key because each student has the key, right? So if each of my students has an ID, which is unique, right? So this guy has key 1, and this guy over has key 2, then what's the point of repeating that? Like, I can look them up by this, right? So then what you could do is you could say, okay, in that case, I don't have keys, but then this is not a proper JSON because an object has to have key value pairs, and I don't have the keys. I only have the values. So then what you can use an array. So JSON also has square brackets, and a square bracket is basically like an array notation. So you can have open square brackets and then just objects, right? One after the other, right? So this is an equivalent of an array of objects. And then I can have 200 students in an array, and then if you parse it, it will not be a JSON object, it will not be a struct, it will be an array, right? So then you can represent multiple students or multiple objects using a JSON array. It's not, you don't have to use it as the top level. You can have arrays inside as well. So for example, you can say each student has, I don't know, subjects they take, and the subjects is an array of strings. So you can say it's math, programming, physics, right? So you could do that. So now I have a field, subjects, which has an array of strings. Can those fields be objects? Of course they can. So you can have nested objects inside the array as well, right? So you have objects and arrays, and then you have strings, Boolean, and numbers as kind of primitive types in JSON. And out of that, you can compose any combinations of different things. What's the advantage of having an array and keys here versus having the original one which I wrote, which is the map of keys to the object? Which one is better for what?
a map.
Yeah, exactly, exactly. So that's a very good point, that if you want to look up, if you want to say, do I have a student with this ID? And you have a map, it's just, okay, you say, give me, you're asking a single question to the map saying, give me the object for this ID. And then you either get it or you don't. And if you don't, you say, okay, I don't have this key. But if you have a list, what do you have to do? You have to go through it, right? So you have to go one by one and check if you have that student in. So if you have 2 million students in the university and you're saying, okay, I need Joe, then how are you gonna do that? You have kind of a long way to find it, right? So for lookups and for databases, we don't do that. We don't kind of go through the list and ask, okay, is that key there? We try to organize it in such a way that we kind of remap it into maps. But sometimes you want to look up by ID, sometimes you want to look up by a name, or sometimes you may want to look up by something else, right? So that's why we usually generate indices, right? So your general data structure will be just a raw list of things, but you prepare your data structure such that the lookup is fast. So if your lookup is often by ID, then you generate a map which points to indices in this list, right? And then you can look up through the map what is the index of the student or object that you're looking for, and just by notation, like, so you probably didn't have this complexity notation with big O. Did you have it in the algorithm form? So if you have O1, it means I just need one operation to find something, right? So sorry, constant time, exactly. So if my data structure has n elements, right? So and n can be really big. Let's say it's 1 million. Then to look up something using a map, it's just a constant time. It doesn't matter how big that is. If I have n, it means, okay, it matters. So if I have 10, it's much faster than if I have 10 million, right? So my operation for looking up here is much faster for smaller data structures and much slower for longer ones. Here it doesn't matter. So we really like these ones because those ones are independent of how big my data structures are. So in the list, if I have to do lookup, it's this, right? If I have to find something in a list, it's that complexity. But if I have to look up something in a map, it's this complexity, right? So, but it doesn't mean everything needs to be a map, because often you don't. You're not doing kind of the lookup this way. So it depends. So those are the two ways of organizing larger numbers of items in the JSON. There are some small issues. So for example, if let's say we go to this, I kind of proposed programming tasks, and one of the programming tasks is this population API, which for some reason doesn't work. So it should work, but it doesn't for some reason. Okay, so let's use something else. So let's use here we have another one, which is, yeah, for example, this one. So yeah, so let's have a look, right? So if I do a GET request, so if I ask for the latest exchange rates, right? So I can go to Postman, or I can go to whatever you've learned last week about interrogating REST APIs, but I can just ask it in the browser as well. I will get a list, right? That list is not organized kind of in a nice human readable way, But if I copy that and I say I do new file and example JSON, let's say latest rates. No. Okay. So you will see that it's a JSON object with rates being the primary key, the main key, and then it has an inner object, and in this inner object I have keys like this. Okay. So I have currencies, and I presume the base currency is US dollar, and all those currencies are kind of what's the current exchange rate versus US dollar, right? So for $1 US, I get 1.4 Canadian dollars, right? So, and the list goes on, and then I have, no, it's actually euro, sorry, it's not US dollars, it's against euro, right? So this, yeah, let's do this, so I don't, yeah, so the list of currencies finishes here, and then it finishes that inner object, which ends there, and then there is another one, which is the base currency, and there is another field, which is the date, right? So I see that the base is euro, and all those currencies are listed this way, right? So now, if you have to prepare your struct, right? You will see that this is kind of really tedious to say, like this object, this JSON object has, I don't know, 80 fields, and all those 80 fields are kind of specified here as a key, right? So if I were to create, a Go struct for this data structure, what will I have? So I will have, so let's say, so I will have to say something like this, right? And then I have 3 fields. I have rates, so we will deal with it in a moment. I have base, which is what? Which is a string. Easy, right? Yeah, so let's not use JSON notation, let's use the, so I have a field rates, I have a field base, and I have a field date, which is also a string, right? I have to convert this string to actual Go date to have type safety. I don't want to have any string here. I would like to convert this to actual proper date object, right? But for the simplicity, I may just say string here for now. If you were to convert this to a date, you would have to instruct the parser that this string actually needs to be converted to a date type. And that's a little bit more extra machinery. So for strings, Boolean, integers, and nested objects, you don't need to do anything extra apart from declaring those annotations, right? So I don't have the, yeah, let me, yeah, that's not what I wanted to show. I wanted to show this one. Where is it? This one, yeah. So if you are declaring a struct for your JSON which has strings, Boolean, numbers, you don't need to do anything apart from mapping which field maps to which field in the struct. But if I were to convert a string from a textual representation to a date, I have to do a little bit of extra. We will not cover it in this lecture, but I will talk about it later, how to do that. So for simplicity, we're not doing that at the moment. we're just saying, okay, date is a string. So date will basically be that string which is here. So now we have this field and this field covered. We have to kind of deal with the rates field, right? And the rates field is what? What is this? What is this here? It's a JSON object, right? And it's a JSON object which has a certain type. So we have to declare another struct for this, right? So this struct will be what? Let's call it rates type, and then this type will be type rates type struct, and how this will look like. So what fields this will have? Exactly. You will have to say cat, and cat is what? Is a float, right? So those numbers are floats, and this becomes if we want to map the name to the name exactly, it will be like this, right? And then I have to say HKD, it's also a float, and so on, right? I have to list all those 80 or whatever currencies I have as particular things here, right, for parsing. Well, one may say, yeah, that's great, because then I only say, so then when I'm looking for the particular rate, right, I would say, so let's say I parsed my rates, I have my rates object R, right, and then I want to find what is the Canadian dollar rates for euro. I would say R rates CAD, right? I would do that, and I would extract the actual number, which is the value of this float, correct? So from a user point of view, this kind of doesn't look too bad. From the programmer point of view, writing this by hand is super tedious. And what will happen if the API, so what will happen if this API, which I have here, right? Where did I ask it? Here. So what will happen if they have added a new currency? Let's say they don't have any cryptocurrencies here, right? But let's assume that they've added Bitcoin, right? So they've added BTC as an exchange rate to euro in this list, and I don't have it. I don't have it in my declaration here. What will happen? It will break. It will throw an error, or it will kind of miss it, right? I will not have it in my data structure because I didn't declare it, right? So if they've added one extra line in the API, I have to go back to my code, recompile it, add this extra line, recompile, rebuild the whole software, and redeploy it to deal with this extra line added there, right? So that's not good. So what's the alternative? Exactly. So what you could do is, instead of specifying all of this as they've done, what you could have done, you could say, well, there is an array of objects which have the currency code, right? So it would have currency code, for example, and the code would be cat, right? And it would have value, and the value will be the float, right? So now if I redone all those fields as this, suddenly I'm much more dynamic, right? Because I can add an extra row, an extra line, and my code works with it. I don't need to recompile anything. It still deals with all the currencies that are there, but I'm much more flexible of what sort of currencies I'm dealing with. And I like if they've added the new line, the new extra currency here, it works. My code still works, right? But that would mean redesigning the structure of JSON instead of using the key value pair for the currencies to use an array or a map which maps particular currency code to a value, and then I can kind of parse it line by line and dynamically add or remove from my array. Yep. No, exactly. So this API is already designed, right? And for this API, we have to live with what they've designed, right? In which case, it's something you kind of swear a little bit and say, and then you go and write this this very long struct by hand, and be a little bit upset that you have to do that, recompile your code, and fingers crossed they're not gonna change much in the way the API works, because every change they do, you have to recompile your stuff, right? But when you're designing your own APIs, you can take it into account. And if you are a programmer who is doing this type of programming of APIs for currency exchange, you will know not to do this. You will know to do it kind of more flexible way, right? Yep. Yeah, so in Go, it will be ignored, right? So in Go, if they've added the currency, your current structure will miss it. It will have kind of ignored it, and then you will not see it, right? But what will happen if they've, because sometimes you don't care what the names are, right? So for example, if I don't know, yeah, let's say, so Macedonia recently changed the, yeah, it's the same. So they've changed the kind of the code, country code, but not the currency. But what will happen if a particular currency changes the mnemonic? Your code will miss it, will kind of stop seeing it, right? But if you do it the dynamic way, it will still work. It will still be in your data structures. It will just have a different name. So if let's say, imagine that you've built a kind of a tool, a mobile app where people can look up a particular currency. So they type like NOK to see what's the exchange rate for Norwegian krona, right? So if they change the code or added something or removed, the app with this flexible thing will work all the time without any modifications. But if they modified the Norwegian krona to something else, then your original code will stop working because you assumed it's always NOK, right? So the design of the API is like, as in this case, it's not up to us. Like it is what it is, and you have to use the data structures that they've generated, right? But when you're designing your own, you can think which way is kind of the easier way to deal with later on for the programmers and for the code to maintain it. Right, so yeah. Do you have questions? Yep. That's right. So yes, it will work. So for example, for this one, for the original one, let's change it back to the original. To the original struct. So this one, if you were to have this full parsing capabilities to be able to do this, you would have to have this struct with listed all the fields by hand, right? So cat, HKD, ISK, PHP, DKK, and so on. You would have to do all of this here by hand. And as I said, first of all, it's super tedious. You would hate yourself for doing that. And second, it's very inflexible because any addition or any change like breaks your code, right? So for this data structure which they've produced, what you will do, you will cheat. So what you will do is you will say, okay, screw it, I'm not doing this. Okay, so I'm not doing this extra work. I will say that the rates is really just a map between a string and a float, right? You would do this, and you would say, okay, let the parser do the rest, right? So the parser, what the parser will do, the parser will take all the keys and put them as keys into this map, and take all the values and put the values into this map, right? And then you would not be able to do this, but you would be able to do the similar thing, which is this, right? And then you can extract the Canadian dollar rates from this data structure by doing kind of just a simple map lookup, right? And you say, okay, let's live with that, right? So that's the kind of the alternative, and that has the benefits of what we were talking about being flexible, because now you don't care if they change knock to something else, it still works, right? If they've added new line, it still works because the parser will add everything to your rates field, right? So in situations like this, we usually give up the type safety and strict typing of the structs, and we kind of go with the map because it's more flexible and kind of easier to deal with. And in this situation, you don't have to create this extra type with all those fields, right? You understand this? Yeah. So for this particular exercise, if you were to parse this rates data structure, that would be your Go struct. Plus, what you would do is you would kind of add those JSON annotations mapping the fields, right? So you would kind of map that the rates field with this map is mapped to this rates field in the JSON, and same for base and for date, right? If you don't do this one, then yeah, I don't know. I haven't tested it with Go 1.13. I don't know what the defaults are. Before, the defaults were that the capital B would be converted to small b, and this would work automatically. You don't have to have those extra things if the name is just one. If you just converted the name by capitalizing the first letter. Why do we capitalize the first letters here? To make them public, to make them accessible from outside the package, right? So if the only thing was capitalizing the names, and the names are exactly like this, you actually don't need this JSON annotations. But the JSON annotations give you, they give you more than just mapping of the names. They allow you to decide what to do if there is no field, for example, right? So let's say I set that my struct has a base property, right? Base field. What will happen if this JSON doesn't have a base? Okay, what will happen? The default is that this field will be null, right? It will be kind of a null thing, but maybe you want to have a default. So using those annotations, you can say, if the original JSON doesn't have a field like I have here, I want to use an empty string, or I want to use euro as a default one, right? And then the parser will do that. The other one is you can say this field is required, right? If my JSON for rates doesn't have a base currency, it's useless. Like, I don't know what those rates are against, right? So if the JSON is missing a required field, the parser will throw an exception. Will say, okay, the required field is missing, right? So you have ability to express certain logic and certain expectations and requirements on your fields for the parser to know what to how to deal with those mappings between the JSON text and your structs. So those are useful to have. So by convention, we usually do them for everything, and then you can add extra things as you need them. Yep. Yep. Yeah, that's right. So so that's what we do with the, yeah, let me go back to the simple REST. So here we specify the mappings, right? We haven't specified anything extra. We didn't specify what's required and so on. So that's a very simple case. And then you have let me see. You have a package called Encoding Json, and this package allows you to convert from JSON to string and from string to JSON, right? So for example, if you have, so what's this? What do I have here? What? Yeah? Who knows what is this? Student is a type, is a struct. So what is this? Yeah? Almost, yeah? Slice, yes. It's an empty slice of what? Of students, of null students, right? So I have a single and null student because I created a single null student and kind of have an empty slice of those empty students. So I actually have nothing, but it's kind of like a placeholder for a type which could be filled in with student structs, right? So then, because this one is an empty one, it does, like, you can imagine that this is actually like a slice or an array of students structs. So then I can pass it to the encode method of an encoder, which is using the W, which is the writer stream, to generate the text out of these objects, right? So to convert those objects to a string which can be responded through the HTTP writer, I basically do this line, right? So I first generate a new encoder using the stream from the response writer, and then I encode the actual objects into this encoder, right? You may ask, okay, what if I just want a string? I don't want to have a stream, I want just a string. Yes, you can do that as well. So you can generate a new string encoder and have something encoding into the string or a string buffer, or you can kind of parse. You can, instead of doing encoding, you can use a parser which will parse your data structure into a string representation. It actually will parse it into a byte representation, and then you can convert it to a string. So all of that is inside the JSON docs, right? So if you go to doc JSON package, you will have all those methods, all those things kind of. So remember the marshal function or marshal process I was telling you. So marshalling and unmarshalling. So you have marshal and unmarshal, right? So marshal takes your data structure, your struct or an array or slice, and converts it to a byte array, right? So this is a very simple way of converting something from Go into something as a textual JSON. And then unmarshal is opposite. You give it a byte stream or byte sequence or string, and then a placeholder for where to generate the data, and it will kind of put it will parse this and put the stuff in here, right? So those two methods are for doing it by hand from byte slices. So this one is for converting struct into a byte slice, and this one is from byte slice to whatever you have, and it will give you an error if something went wrong. And then you have more fancy APIs for doing like streams, and that's what we use here. That's what we use here, because we don't want to be manually by hand converting this to a byte array, converting this byte array to a stream, and so on. We just use the encoder to do that for us. So we know we need to generate a byte stream into the HTTP response. So we use the encoder with the like a write buffer for doing the encoding. And then the opposite way, so this is for generating the response. And then for the opposite way, if you were, so all of these will be here we have, so this method asks us for all the students. So we have all the students in some form of database or a list or whatever we have here, and then we generate JSON, right? So we take our students. So here you see we have a list of all the students, and we encode them and then pass them to the whoever called us, right? So we created kind of a list of all the students by appending kind of students one by one, and then generated the response to whoever asked our API. And then this one is we posting a JSON into the API saying add this student into your database. So we're actually sending a JSON in, and now we have to parse it. So it's a string, and then we have to generate a struct. So how we do that? Well, first we have to have a placeholder for the struct. So we say, okay, we have an empty S, empty student, and then we have the body from the request containing the JSON, right? So then we're saying, okay, again, create a new decoder this time, not encoder, but decoder, and then decode whatever is inside body into the S, right? So we're passing a pointer to S to fill in all the fields, right? So that's the opposite action to the one which we've done before, and in this one we kind of handle the errors, right? Here we said error handling is missing. We kind of not handling errors. We should, right? Here we're handling errors. So for most of the course, you will be basically using those decoders from either the response writer or from the body of the request to get the JSON in or out, right? But if you need to handle JSON manually by hand, you can use those Marshall and unmarshall functions to do that kind of manually. And if you were to handle this case which I was describing before, like you have a string, but in your struct you want to have a date, for example, right? Or you have a float, but you want to round it up and have just integers or whatever conversions you want to do. Then what you do is you have your struct, and on that struct you define a Marshall and unmarshall methods, and the parser will use your methods to do the conversions between the byte stream and the type, and the type and the byte stream, right? So if I were to do this mapping, and I said that this one is something else, maybe it's yeah, I don't some form of date type from Go, right? Then what I will have to do is I will have to have a func which is on top of the rates, and then I will define the Marshall function to say if I'm parsing this, I am kind of doing manually what the parser automatically does, and then for this field I would kind of do what I need to do. So I will read the string, convert it to date, and kind of inject into my data structure, right? So that's what you would need to do if you were to do a little bit more advanced parsing of JSON. Otherwise, you can let it be, and the default behavior will kind of most of the time do what you need to achieve. Make sense? All right. So let me go back to this one again. So here, Christopher probably went with you through this example, right? He did last week? No? So this is like a cut down version of a larger example, which we use for explaining kind of building up a REST APIs. And if you go to the wiki of the course, I have put videos from which kind of explain this. So all the student examples which we have in the Git are kind of explained in those three videos. So we go from zero to building up those student data structures in memory database, and then the building up the API for being able to ask the API for the students. So I want you to watch those, right? So those three are about this student API, and then today, what I was planning to do was kind of catch up on like where you are with Go, and also check up the programming tasks, and that's what this video is. And then this one is a simple kind of a request, for example, for getting this type of data, right? How would you get this in Go from the API, right? So that's what this lecture is, that one. So this one and this one, please watch today for tomorrow. And these three you can watch after tomorrow for next week, right? So these ones are for this code base, but instead of like showing you the code base from like the whole thing from the onset, we actually go step by step. We're building it like one by one, how you can build this simple student API for storing and recording student data, right? And that's a kind of like a template which you can use for anything, right? We just use students as a simple use case, but the patterns are the same. The parsing of JSON and so on is always the same, right? So I would like you to check those later on, and then we will have more advanced discussions, and we will talk about databases. So later on, we will talk about Mongo and some databases of how to store JSON. Yeah. What is what? The request? A request body. Yeah. Okay. So let me just check something. Yeah, let's see. It is related. All right. So HTTP. All right. So here you have so one of the things did Christopher talked about those? Yeah. So one of the things that HTTP kind of provides us is the organization or the structure of the requests and responses. And the response usually has a header. So this part here is the response header, and it's basically first line is always specifying the version of the HTTP protocol. So it's kind of a versioning and the error codes, right? So we see that everything after that will be following HTTP protocol version 1.1, and the error code for that request, which we're sending this response for, is 200 OK, right? And then we have the header, and the header is key value, right? So it's kind of like in JSON, but you don't have to quote the keys. The keys basically is anything before the semicolon, right? The colon. So anything before colon is a key, and then everything after is the value, right? So we see we have 1, 2, 3, 4, 5, 6, 7, 8 fields, which are key value pairs, right? One of them is content length, so it says, okay, the body will have 138 bytes, and you know what's the accepted ranges, like we're sending bytes, and then the connection is gonna be closed after the response is sent. And then there is an empty line, and then after this empty line there is a body. So this is the body of the response which was sent based on the request, right? But when you're sending a request, you're doing exactly the same. So you have a request header, which has whatever the protocol is. Then you have the certain number of header fields. Then you have an empty line. And if you're doing a GET request, there is no body. You only have a header. But if you're doing a POST request, usually you have a body. So you may have a POST request with the body being empty or a body being something. In this case, the body is an HTML, but often when we deal with APIs, we use JSON, right? So the request or response body is basically the content of the message which is being sent between the client and the server. Does it make sense? Yeah. So now all those fields are kind of easily accessible from Go. So if I go again to this thing, so as you see, I have a handle to the request, and then to access the headers, there is a map which maps the key values of the header out of R. And to access the body, I just say R capital body, right? If you look this up, if you look this, let's use one more. Doc. So if you type, what are we looking for? For request, yeah, that's right. So if I go to the request, then I have some fields, right? So one of the fields of the request is capital .url, right? So that gives me the whatever the original URL was for the request, and the other one is header. As you can see, it's a map between strings and a slice of strings, right? So the value can be more than one string, right? I have to iterate over the values, and the key is single string, and I access it by saying .header, right? So if I were to, so for example, if I do this, right, I copy that. So if I were to access, so if I have this R, which is my request, and then I say header, then I would say this, and that would give me what this will return to me. So if I say a like this. What is A? Yeah. Yeah. So A would be what is the type? So if I declared A, what is the type of A? No. But close. That's right. So it's a slice of string, right? So A is a slice of string, and if there is just one language, like in this example, en under minus us, then it's just a slice of a single string, right? But actual type of A is a slice of strings, right? So if I do this, then I would have to say, okay, give me the first one, right? If you just want the first one. Make sense? So then you have some other things like a header, a body. You see, it's just right there. So you say you have how big it is, and so on and so forth. So that's for the request. And then if I look up response, so yeah, I need a response. So I have a request. Let's go to response writer. So response writer is again an interface, and then it has also a header, and it has ability to write the body, right? So when I'm preparing a response, like let's have a look here. So I have to send, for example, here, right? So somebody asked me for all the students, right? And then if I have nothing in my database, I basically return an empty slice. So what will be the response? What will the so if I did get blah blah blah, which maps to this function, what will the client get? What will be the error code? Nothing. 200. So everything okay, right? So the default error code is 200. So the client will get 200. What will be inside the body? What will this line generate? Empty slice, but in JSON there is no concept of slices, so it will be an empty array, right? So yeah, so it will be basically an empty array of open square bracket and close square bracket, right? And that's it, right? And there will be a default, some of the default headers, such as that the response is in I believe text plain, and then the length of the response will be calculated to those two characters, right? So all those things will be filled in by default. So I'm not saying anything here. Those things will be set by default, right? This one will be the same. The error code will be 200. The response type will be probably text plain, not JSON, right? So if I want to say that the response is application JSON, I have to say it myself in a header. And then the content length will be calculated correctly, right? So if somebody asks me for a student, right? So here we're getting a request for a particular ID, right? So I either have this student or I don't, right? So here I'm checking, okay, do I have this student? And then if I don't have this student in my database, so okay is not okay, it's false, then what I'm doing, I'm saying, okay, please prepare an error response and use the writer to generate this error response. And then the error code will be HTTP not found, right? And that's what the response error code will be. And then the body will be also, so the error code is here. So the response will be the first line where we're saying HTTP 1.1, and usually you have 200 OK. This one will have something else. So to look up what status not found. Out of memory, do you know what error code is that? That's right. Exactly. You can look it up in RFC, but anyone has an idea? What error code is that? So if I say, so what's that? So I ask Google to give me something, some rubbish, right? And Google tell me, okay, 404, what's that? 404 is not found, right? You've seen it. You often go to a page and it says 404. That's exactly an error code, HTTP error code for not found, right? So if I were to guess what this will be, it will be 404, and then we basically getting a text representation of what 404 is. And in Go, 404 basically will say not found, right? So you can look that up in Go docs as well. So what you could do is you could say, I want to find this one. So I go doc. Status not, you see? So I have all those error codes here, and status not found is here, and it's RFC 7231 section 654, and the error code is 404, right? Make sense? So depending how I want to cope with the error, I will pick appropriate one, right? So for this particular case, oops, sorry, if the client asks me, give me a student with this ID, what should I say? Well, you have some options, right? You may say there is an error, there is internal error, or there is whatever, right? So you have all those possible things, but not found seems to be the most appropriate. So if the client asks me for a particular student and I don't have it, it's like saying I don't, yeah, the student has not been found. This is the best one, right? So all errors 4 are about what? Yeah, so it's kind of those are errors which are not really about the client, but they are not really about the server neither. So they are kind of a typical errors that like something is not working quite well, right? But it's neither the fault of the client or the server, right? Errors 500, server errors, right? So 500 always definitely something went wrong on the server. No client's fault, something went wrong on the server. So 400 kind of application layer errors, right? 300 kind of you see we have moved permanently, multiple choice, use proxy. Yeah, redirections, exactly. Something kind of auxiliary, some redirections, right? So temporary redirect, permanent redirect, redirections. Okay, 200. Yeah, typically no error. So same thing. So you could say, should I respond, for example, no content 204 instead of 404 for a request for a student which I don't have in my database, right? Yeah, it's kind of a matter of taste a little bit, right? If I ask about a page which doesn't exist, typically we get 404. We typically don't get 204, right? It is kind of an error, right? Somebody is asking me for something that doesn't exist. Therefore, right, it should be an error. When would you use 204? Yeah. For example, that's right. Or if you ask for an age of a student that you have in the database, but you don't have that age, right? Then you say, I have a student, I just don't have a content for that particular field, right? So it's not really an error, it's just the state of how my database looks like, right? Or something like this. So 200 usually not an error situation, it's just kind of a usual situation. And then 100, yeah, something to do with the protocol layer, right? So we kind of continue switching protocols, processing, something kind of to do with, so 400, some of them are client, so yeah, you said kind of a client side. Some of them are client side errors, right? So for example, a client is not authorized, or for example, there are like the yeah, exactly, too many requests, or the request is malformed. Yeah, so things to do with the client might have a 400 error. So in our case here, oops, what we say is if we haven't found a student, we have to generate the error. Otherwise, we just pass back the student. But we don't explicitly say here HTTP 200. It's kind of default, right? So a lot of things happen and go by default, and sending 200, setting up the encoding and content length and all those things are kind of automatically there. So you can always interrogate it using Postman to see how the header of your response looks like, even though you're not sending it, right? All right, any questions about this? Right, so JSON is kind of clear. Parsing and generating, not super clear, but you know where to look up. You know the API. Generating the structs and using maps, good idea. So let's do two things. So we have 15 minutes. Hopefully we will do two things. So the first thing is in the programming tasks, we can do the first one hypothetically. It's more explained more in the video, but the first task is, whoops, it's not, it's missing. So it's not missing, it's just on the main pages wrongly specified. So the first task is write a function that takes two integers and swaps their values. So how would you do that? Who knows how to do that? Yep, who else knows how to do that? So write a function swap, which takes two integers and swaps their value. So if I have a 10 and b 20, and I call swap a b, now a is 20 and b is 10. So who knows how to write this function? Okay. So how would you write it? What do we need to do for this to work? Yeah. So we need to pass pointers, and then do what? Yeah. So we can do this, right? And then when we actually call them, what do we need to do? We need to pass pointers, right? So what would happen if we didn't use this, and if we didn't use the pointers? What will happen? That's right. So here it would be 10. Here a would be 20, right? So within the body of the method, a would be 20 after the swap, but outside of the method, a would not be touched, right? A would be exactly the same. But if we do this with the pointers, and if we do this with the addresses, then outside it's 20 and inside is 20. Everybody understands this? It's pretty simple, right? So simple pass by value or pass by reference. So if you're passing by reference, you can modify the original. If you're passing by value, there is a copy, and you're only modifying the copy, right? Okay, so that's simple. So now let's do the second one. So write a function hex that takes a string and produces a string. The function converts characters A to 10, B to 11, C to 12, D blah blah blah, such that a given input AAA will produce 10, 10, 10. And given input string ABC, it will produce 10, 11, 12, and so on, right? So incorrect inputs, for now, you don't deal with it. So the simplest version is you're just writing a function that takes, so the function is called hex. It takes a string and produces a string. And then the function looks like, so let's say return 10. So that kind of is an example. And then if you call it, if you call hex with AAA, it should return 10, 10, 10. If you call it with ABC, D, it should return what? Exactly. So how would you write this function? Ideas. Yep. Yep. So that's the simplest and also the best way of doing it, right? But if you were to do it really, really naively, right? Yeah, let me just copy that because I need a goal. So it sort of works. So let's get rid of this one. Okay, so we need so for we don't need an index and the v range A. Will that work? So now I need to look up of what v maps to, right? So as was suggested, the easiest way is to have a map which defines our mapping, like what A maps to, what B maps to, and so on. An alternative is you could write a switch statement, right? So you would say, you could convert it to an ASCII code and then do kind of subtract to map it to A to map to 10, right? So you could do that. But that is a little bit inflexible because if you were to go by 2 or to go by kind of a weird mapping, then it wouldn't work, right? So you would still need to kind of put that logic in. So the easiest way is to have a kind of a constant definition of what this mapping is, right? So I could say default map, and this is a map of string to to string, and then you say that yeah, you actually don't so a maps to 10. Yeah, I don't think I need yeah, let's not mess up with consts for now. We just do B11. So then in here you would say so result is a string, and result plus dn from v. Okay, so we have a skeleton. We don't have a correct syntax for in the spot defining a map, right? As a map literal. Do you know how to do it? How to define a map as a literal in Go? Yeah. So we have to look that up. So we almost did it right, but we need to specify the type. So we have to say it's a map between a string and a string, right? So then you have a map literal. So this one, let's see if it will work with constants. Not really. Yeah, but for the sake of argument, let's say we don't need for it to be a constant. So then what we would do is we would kind of specify all the spec for our conversions. And now if I run this function hex, it yeah, because it's a not really let's see if this will work. And we use the characters. All right. So now it will work because it will look up the. So we iterating over our string. We get the character. We look up to what string that character maps and just append it to the final final result, and we return the result. Make sense? Why this one is the best solution instead of doing the loop with, so instead of doing that, what we could do is we could say we have a switch, we switching over v, and then we saying case case a result plus equals 10. So if I do this, and so on. Instead of doing this and this. What's the difference? Both will work, right? Which one is better?
By the way, instead of going through all Python with two switches, each time you want to look.
Right, so about the switches, in Go, if you don't say continue, the break of the case happens at that point, right? So the switch statement in Go is a little bit different than in other languages because you don't have fall through. It kind of, once you hit the particular case, the switch statement stops, right? So you don't have to say break, it kind of breaks automatically. So that's one thing. Second thing, is this faster than this? I don't think so. I think it will basically compile to kind of similar lookup, right? Yeah? Exactly. That is true. So that is a good point, right? So possibly if you have a long case statement, it would be slower, right? What else? So this potentially is a little bit slower than this. What else? Yeah. Exactly. The first one is much more readable and much more maintainable, and it isolates the logic of the processing from the specification of what can be isolated, right? So here we're mixing what is the mapping and how the mapping is done, right? Here we isolated the mapping and how it is done into two spots. And what does it give us? Well, it gives us that, for example, we could read this from a file. We could have a text file where we read where, how the mapping kind of works, and in the text file change it. And then the program doesn't need to be recompiled. It will work with a new mapping. Whereas if I want to change mapping here, I have to go to my source code and modify it and recompile everything, right? So again, from maintainability point of view, flexibility point of view, and from readability, this solution is much cleaner and much nicer, even though they appear kind of identical, right? They kind of do exactly the same thing, and they kind of look similar. So this one is preferred, and there is one more argument for preferring that one. When you will be working on your projects, we will ask you to do some analysis of your source code. And one of the analysis of the source code is called cyclomatic complexity. Who knows what that is? So cyclomatic complexity is a metric telling you how complex your function is, right? And the idea is that complex functions are hard to maintain, they are easier to have bugs, and they are harder to debug. So keeping the cyclomatic complexity low means your functions are kind of more maintainable and less likely to have bugs. Even though those two lines, those two solutions look almost exactly the same, if the mapping is quite large, if the mapping has like 10 items, the cyclomatic complexity of this will be will be bigger by 10 than this solution. Why? Because each case adds an extra complexity to your code. So every if statement, every else statement, every case statement adds complexity to your method, right? So having a switch with like 10 cases is already ramping up your cyclomatic complexity. So you can Google it, cyclomatic complexity, and read a little bit about it. There are different ways of measuring it, but in general, we kind of use whatever the Go tools have and whatever the complexity is calculated. It's basically an abstract measure of how complex your function is. So this one is much simpler than this one using that metric. All right, so I will finish for today. What I would like you to do is watch the videos, and what we will do tomorrow is we will set up Heroku, and we will do a very simple student-based API where we can ask the API deployed on Heroku. Yeah? Yeah, it said no class, but I think we should have a class. Okay, so I will change it. Yeah. So I will change it now. Just give me a second.
One down.
Yeah, this one. All right. Right. Let me just finish this.